Check 1, 2, check 1, 2. Lesson 103. This is all about volume. So, what is volume? Volume is the amount of space that an object occupies. These are geometric figures that occupy space. They would include cubes, spheres, cones, cylinders, pyramids, and combination of these shapes. In this lesson, we are going to concentrate on finding the volume of rectangular solids, okay? So we're just getting into the rectangular solids in this lesson. This lesson is a bit longer. It is on the front and the back. I've given you the sheet to cut these examples out because they are a little bit lengthy, but hopefully by the end of this lesson, you will understand volume. So, how do we measure volume? We measure volume in cubic units, okay? So this line right here is a unit segment to measure distance. Okay? Because we measure distance in length, like how many inches, how many meters, how many feet, how many kilometers, okay? That's how you measure distance, with just like one line that you can measure that way. This is square unit. And what do we measure with square units? To measure area, okay? So like if you were going to measure your kitchen floor, you'd say, like pretend it was tiled. You'd say, how many square units does it take? You could have a square inch, square centimeter, square foot, okay? A meter squared for your measuring something like that's still flat, but you're measuring how much area it takes up, okay? So we've got this to measure distance, this to measure area, and we've got cubic units. See, it looks like a cube. Cubic units. And those measure volume. And you will understand a little bit more about that, or a lot more about that, as we go on the lesson. I'm going to add another rubber band to my thing right now so it stops shaking. All right, and I hope that this is in focus. Maybe that will change anything. Okay, example 1. Give an example of a unit that might be used to measure, oops, this didn't copy correctly. Measure, put an E on the end of that. A, the amount of molding around a room. Okay, so put your A over here because we're going to answer these. So the amount of molding around a room, are you going to measure that in distance, area, or cubic units? You're going to measure the amount of molding around the room with distance, okay? So you're going to use feet. You might use feet. And that is measuring distance. Okay? B says the amount of carpet on a floor of a room. Okay, carpeting is a physical example of area. Okay, so you might use square feet. And that would be area. And square feet would be like feet squared. Okay? But this is square feet squared. So you could just write square feet or feet squared. And C, the maximum storage capacity of a room. That would mean how many, so in that room, how many boxes could I fit? Oh, say, pretend it was a storage unit. How many of these boxes that are cubes, right? Because it's a box, 3D shape. How many boxes could I fit in that storage room? So you're going to use cubic feet or feet cubed, right? Because you're measuring volume. All right, example 2. Find the volume of this rectangular solid. well, to find volume of an object, we calculate the number of cubic units that the space occupies. Okay, so when we're looking at this, each of these cubes occupies 1 cubic unit of space, and we can see that it's 2 centimeters this way and 3 centimeters this way. That means that each of these cubes is 1 cubic centimeter. Okay, so how many 1 centimeter cubes would we need to find out how many are in the solid? The solid is 3 centimeters long, 2 centimeters wide, and 2 centimeters high. Okay, up here, you're going to write volume equals length times width times height. Okay, length times width times height. All right, and so we see 2 times 3 times 2, okay? So this is 6 times 2 is 12 centimeters cubed. That is the volume of this rectangular solid. Example 3, what is the volume of this solid? All right, so it's inches. 2 times 4 times 3. That is the length, width, and height. Okay, so we get 8 times 3 is 24 inches cubed. Okay, so if it's 3 high, then you're going to think each of these is how many, each level is 2, 4, 6, 8, and then 8 times 3 is 24, right? And then it says, notice that examples 2 and 3, we found the number of cubes on the bottom layer, okay? So how many cubes are on the bottom layer? We did 3 times 2, okay? That's the length and the width. So there'd be 6 in this, 2, 4, 6, and then we multiply it by 2. Okay, we do 2 times 4, and then multiply it by 3. So you're finding the number of cubes. And multiply by the number of layers, which is the height of the solid. We can find the number of cubes at the bottom layer by multiplying the length and the width of the rectangular solid. Then we find the volume by multiplying the height. Volume equals length times width times height. Okay, there you go. Length, width, height. This should help explain it more. Now, flip to the next page. This is your next examples, of course. Example 4. Emma keeps the quilts that she makes in a sturdy cardboard box. A, she plans to cover the top of the box with fabrics. Choose a formula and use it to decide how much fabric she needs. Well, the top of the box is a rectangle, and fabric covers the area of the rectangle. So we're going to use the formula area equals length times width, right? So the length is 24. We can see that right here. So area equals 24 inches times width is 36 inches. All right, so the area equals, you're going to do 24 times 36, and you're going to get 864 inches squared, okay, because it's area. So it's asking how many square inches does she need, Emma, need to cover this top of the box. And B, how much space is inside the box? Choose a formula and use it to determine the volume of this box. We know volume equals length times width times height. Okay, so volume equals 24 by 36 by 24 again. Okay, so you're going to multiply that out and find the volume equals 20,736 inches cubed when you multiply that all out. Number 5, example 5. As Dion ate breakfast, he estimated the volume of a cereal box. What was the approximate volume of the cereal box? So approximate and estimated means we don't need the exact number. So we're going to round. We're going to round. So volume we know equals length times width times height. So the length is 7 7/8. We're going to round that to 8. The width is 2 3/4. We're going to round that to 3. Okay. So we get 24 here inches. And then we're going to multiply that by the height, which is 12 1/8. We're going to round that to 12. Okay, so 24 times 12 is 288 inches cubed. Okay. That is the volume of the cereal box. And example 6. Dion wanted to find the total area of the outside of the Saxono's cereal box. That sounds delicious. Some math cereal. He decided to cut open the box and he laid it flat. He noticed that the creases divided the figure into 6 rectangles. 1, 2, 3, 4, 5, 6 rectangles. Each rectangle is one of the panels or faces of the box. To find the approximate area of the outside surface of the box, he estimated the area of each rectangle. Then he added the 6 areas to find the approximate area of the outside of the surface. So we are rounding the length, width, and height to the nearest inch. Okay, so this base right here that we have is about 8 inches, okay? And we know, so he's finding the area, right? It says I'm on example 6. I'm sorry. In my book, I was looking at example 5. It was confusing me. Okay, yes. So we're finding the area. No, we're finding the total. Okay, so yes, area. So we're going to use this as 8. We're going to use this as 12. We're going to use this as 3. Okay, so we're doing length times width of each of these. So we know this is 8 still. So this is going to be 24 inches, this little area. And then this is 8 times 12, so that's 96 inches squared. This little one, see this panel is the same as that one, so that's 3 by 12, so that's 36 inches squared. This one is 8 by 12 again, so this is the same, 96 inches squared. This is the same as that one, so that's 36 inches squared, and this one's the same as that one, so that's 24 inches squared. Now we've got to add them all together. So I'm going to start with the top and work my way across that way. So we've got 24 plus 36 plus 96 plus 36 plus 96 plus 24. I wrote that completely out, and I should have written it out going up and down because it's easier to measure. 24, 36, 96, 36, 96, 24. Okay? I know that 6 and 4 is 10, and 6 and 4 is 10, and 6 and 6 is 12. So that's 32. And then I'm just going to go, and these is 5, 13, 22, 25, 34, 36. All right, so the approximate, oops, I did that wrong. It's 31. 312 inches squared. And that is that lesson for volume. You will need to do in your homework for tonight, all of the lesson practice. And for your special symbol that you're supposed to add, I would like you to circle the length times width times height that you wrote at the top of your paper, okay? Because that is the formula